is the Euler. Here G, hence the following of the G plus E is the Euler, so that G has a closed Euler trial. Now it is a P is one of the edge if I take, it is the G plus E. Now follows that P minus E is also open Euler trial in G. This completes that is a proof of the sufficient part. That's all. This is comes to the Euler trial part. It is if I take, it is called the characterization of the Euler part. But example, he will ask that is examination. Directly will ask the question, characterization of the Euler trials. Discuss that as a statement, state and prove. At the time, directly you write this is a theorem, and directly you can write that because of it is a Euler trial. If you mention that is a Euler trial, you should apply this. Next, if we mention particularly Euler graph, if we mention particularly, at the time you should go for that is this theorem. Example, graph Euler theorem, Euler trial. Now, next, arbitrarily traceable graph. Arbitrarily traceable graph. It is a Euler graph I am taking. See here, Euler graph. Here I started here. From it is going to here, going to here, going to here, and another edge. It is going here. V3 to V5. Vertices are repeated, but edges are not repeated. So this is called as a Euler graph. I am taking here vertices point of view. Here V1, V2, V3. Vertices are repeated. Vertices are repeated. Therefore, I can say that it is called as a Euler trial. Euler trial. Now, in this Euler graph, edges point of view, if I discuss, this Euler trial is clearly Euler graph only. Because of no edge are repeated.
Euler graph.
Yes, it is a vertices are repeated. But this is a Euler trial. But also it is a graph. So Euler true only, it is clearly. So that's what a Euler trials are the Euler graphs, but it's a Euler graphs is clearly Euler trials, but sometimes it is a Euler trials, it is not the Euler graph. That is only the proof of the previous one. This is an example of the graph. Although it will be the following that is observations from the above theorem. The friend here, sir, we graph and explain. This is comes to the graph. Here, what is the total concept of this? It is comes to the Euler tree only. V3 is a repeated. V3 is a vertices is a repeated. Therefore, it is called as the Euler trial. Now, it is coming to the graph is clearly moving to the only one edge. Therefore, it is comes to the Euler graph only. The graph only. That is only the example for the year. Next, it is clearly traversable means it is moving from the one vertices to another vertices. There is no issue for that. Now, Euler graph G is that is exists the vertices B. We such that the Euler tour is in G. G is a finite union of the edge. Disjoint cycle such that each cycle starts and so ends. Therefore, it is a V is a G is arbitrary cycle. That we can say that. Next, coming to the this observation of the graph. This is a Euler graph only, but vertices are the repeated. Vertices are the repeated. It is a not arbitrarily traceable, Therefore, it is comes to the Euler graph only, but it is a Euler trial also. This is comes to Euler trial also. Now, Canning-Burn. What is the Canning-Burn means? It is a soldiers from the river outside. This is the middle is a river. But the soldiers has to move from that side C block to D block and D block to C block. But one person is coming, opposite person should not come. So that's what it is. They decided that one of the graph is called as a Euler graph. This is Euler graph is clearly one of the example of the Canning-Burn bridge. It is a repetitions are not allowed. Edge repetitions are not allowed. That is comes to the graph of the Canning-Burn problem. Now it is called as a Canning-Burn is a 7 bridges we have. 7 bridges means once you check here. This is a first one is a bridge. I am showing here 1, 2, 3, 4, 5, 6, 7. 7 ways we have. 7 bridges we have. So that 7 bridges game is called as it is a Euler graph, and it is comes to the Canning-Burn bridge problem we called. Now here theory will be there. It is a 2 vertices. It is coming to the this is a way. Here bridge is I am connecting. This is a one loop. This is a closed connected loop, and this is also another connected loop. Like that here I mentioned this is a graph. Here it is mentioned in the developed in the 1736. They developed this is a kind of the graph. How the walk will be the possible? Walk will be the possible. That possibility they are identified. It is impossible to move to the one person or both the person to the opposite sides. So that here they developed that is a one edge, the one joining edge. It is coming to the one bridge is between the one person will go to the other person. Like that, it is how the walk will be happen. That is total discussions they discuss. Whenever the not a Euler graph, not a Euler degree is a 3, degree is a 3. At the time, it is not possible to walk. It is a Euler degree. At the time, it is not possible to talk. So this is a okay. Actually, time up, Amma. We will discuss in the next class this concept and Euler theorem and graph theorem also we will discuss. Okay.
Okay, sir.
Okay, anyway, thank you all. In the next class.
Thank you, sir.
Amma, I already informed that exam point of view, you should refer the last five question paper. Okay.